Mars, the red planet, is in trouble. Something has perturbed its orbit. Mars is off track and plunging toward the Sun. Problem is, that trajectory puts the red planet on a collision course with Earth. Fiction, maybe, but make no mistake, the odds are that such an impact has already rocked Earth to the core and dealt us the luckiest blow.
The Earth apparently really was hit by something nearly the size of Mars. We got a moon out of the deal, and it was a good job, too, because the Earth would be a very different place today if we didn't have the moon.
Our moonless proto-Earth, awaiting that lucky strike.
Earth Mark I, the planet that existed before the moon-forming impact, was completely destroyed by this impact event. And the Earth that we live on today, Earth Mark II, is a completely different planet than it would have been had the moon-forming impact not occurred.
It's a simple question, but only recently have scientists pondered, what if we had no moon? If we had no sun, there'd be no life on Earth. Indeed, there'd be no Earth. But what of our nearest celestial neighbor, the moon? Without it, there'd still be an Earth of sorts, but devoid of land-based life. Pluto is the only other planet with a relatively large single moon, but these tiny remote bodies are icy planetoids and don't really count. Jupiter, largest of the planets, has 16 moons, but like those of the other gas giants, Saturn, Uranus, and Neptune, these moons are comparative dwarfs. Jupiter and its satellites resemble a mini solar system. Mars has 2 diminutive moons, most likely captured asteroids. In certain ways, Venus is Earth's twin, but the similarities don't stretch to a sidekick. Venus is moonless. So too Mercury, barely bigger than our moon and closest planet to the Sun. Within the solar system, only Earth has one big, lucky moon. How come?
You don't want a theory that's so evolutionary that it happens to every single planet, because then Mercury should have a big moon, and Venus should have a big moon, and Mars should have a big moon, and they don't.
If Moon and Earth form together in the embryonic solar system, like Earth, the Moon should have a big iron core. It doesn't, so the theory is suspect. What about the capture theory? Does Earth take hostage a passing planetoid? No dice. A body as big as the Moon just keeps on going. A third theory has the semi-molten proto-Earth spinning so fast that a lump breaks from the equatorial bulge. But the physics don't add up. As NASA prepares to go to the Moon, scientists seek a more plausible explanation.
Harold Urey, the geochemist who was involved in the early planning for the Apollo missions, made some remark that none of the 3 theories work, so the Moon must not be there at all.
But the Moon is there, and from 1969, 6 missions ferry 12 astronauts to the lunar surface.
I was strolling on the moon one day.
But the first Apollo landings are about flags and footprints. Later, though, astronauts look for so-called Genesis rocks, material dating back to the formation of the Moon. Do they solve the riddle of the origin of the Moon? Altogether, Apollo missions return 840 pounds of moon dirt and rock to Earth.
2, 1, 0. This is the other ignition. What a liftoff. And liftoff. Roger, ignition.
As soon as the first Apollo expeditions came back from the Moon, there were a series of annual conferences in Houston to look at the rocks that they brought back and talk about the chemistry and the properties of these rocks. People called them the rock festivals. There was one every year.
The results are disappointing. The rocks resemble those in Earth's mantle. They contain no water and little iron. These are no Genesis rocks, and no wonder. Over billions of years, a cosmic bombardment had destroyed the oldest rocks on the lunar surface. To a degree, the hunt for Genesis rocks was a fool's errand. Man walks on the moon, and the origin theorists a little the wiser.
A number of scientists got together and started thinking, you know, it's been about 10 years since the end of the Apollo expeditions, and we were supposed to be learning about the origin of the moon and the early history of the moon. Why don't we have an answer yet?
By concentrating on rock analysis alone, Hartmann believes his colleagues missed the big picture. Impacts, he's convinced, are the clue. The moon is a stark record of 4.5 billion years of strikes from space. And the moon's taken some mighty whacks, not immediately obvious from the hemisphere that faces Earth. Prior to Apollo, when the hidden lunar face was barely known, Hartmann had tried to map the craters at the edge of the visible hemisphere. In a lab, he and a colleague set up a special globe.
We projected the very best photographs on that globe and walked around to the side and discovered a whole new class of features that people had missed. Big concentric scars, which are giant, giant craters, 1,000 kilometers across. And that was one of the links in my own thinking, that the moon had suffered large impacts and that there were very large bodies running around the solar system crashing into the planets at the beginning.
And for every impactor on the moon, 25 hit Earth. By 1984, Hartmann is certain. The small iron core, the bone-dry rocks like those in Earth's mantle, the moon has to be formed from the mother of all impacts. That impactor has to be the size of a planet. But can worlds collide? From Russia, a new theory of planetary formation suggests they can and do. Our infant solar system is a maelstrom. From a vast primordial cloud, particles clump together. They grow as big as basketballs, aggregating, colliding. Soon they're like mountains. The process takes up to 100 million years. We're in the final stages of shaking out the planets. A planetoid blasts the mantle off Mercury. Debris heads for Venus. Beyond is Earth, third rock from the Sun. But next, in the gap before Mars, an extra planet, a rogue stranger called Orpheus. It orbits too close to Earth. On the next approach, cataclysm.
It's a very elegant idea, this idea that occasional big collisions affected the planets, because it allows us to explain why one planet has one type of system, another planet has another type of system. And yet, if you back off far enough and look at the planets in gross detail, they are relatively similar. So you get the similarities, but you get these individual quirky differences.
Venus, for instance, rotates backwards, the result probably of a great smash. Mars has a similar tilt to Earth, a clue maybe of another great impact. The gas giant Uranus rotates on its side, knocked over by a body the size of Earth. Enter a world leader on impacts. Based like Hartmann in Tucson, Arizona, Jay Melosh is skeptical of the Orpheus theory, but he's keen to test it.
As scientists, we are very interested in what happens when two planets collide together. But we'll probably never be able to do experiments with actually colliding planets. And so we have to find some other way of getting the information about what happens during a planetary collision.
Melosh turns to impact specialists, the military.
What we do is the same as the military when they are faced with a problem of determining the effects of above-ground nuclear explosions. We go to a computer code.
Across in New Mexico, a chance word with an insider gains Melosh access to a computer at the Sandia National Laboratories.
This is a classified computer, and so I wasn't allowed to touch the keyboard. My colleague asked me questions about inputs to the problem. And he, for example, asked me, what's the diameter of the target? And I gave him the diameter of the Earth. A few heads came up in the room. Target's the Earth. Then they asked the diameter of the projectile, and I gave them half the Earth's diameter. A few more heads came up around us. And then the velocity of the impact, 11 kilometers per second. Finally, because of the enthusiasm of everybody in the room for this gigantic collision, it was run under highest priority. The results came out. We could see collision of a planet. We could see this massive blast of gas coming out. And it was that kind of simulation that allowed us to go a lot further in understanding what happens in this impact event.
So how is it when worlds collide?
You've all seen movies of colliding planets and things like Star Wars where planets blow up instantly. That's not the way things really work. Planets are so big, things happen slowly. If you stepped back from the Earth 4.5 billion years ago on that day when the planet Orpheus collided with the Earth, you'd see things happening in apparently slow motion. Orpheus would come in, a body about half the diameter of the Earth, and slowly, slowly smash into the Earth, penetrate it, and clouds of vapor would shoot out, but all over about 20 minutes to half an hour. The collision, in fact, would make a lot of vapor that would squirt out. And vapor doesn't obey the same rules as solid rock does. It expands under internal pressure. And that actually allows a fair amount of material to get into orbit around the Earth.
Hartmann gives us the impact. Meloche puts the debris into orbit. But how does that debris form a moon?
It's really sort of a random chance what body collides with what other body to yield the final planets. One of these chance collisions happened to occur at just the right angle with just the right speed to form our moon. And when you view it in that way, the fact that Earth ended up at such a habitable distance from our sun with our large moon seems to be a very fortuitous event.
No such luck for Mars. 2 little satellites, one of them destined to hit the planet. An impact smashes an inner moon of Uranus. It leaves the planet with a set of rings and a reconstituted satellite, the moon we know today as Miranda. Saturn and its rings, billions of particles, as small as sand grains, as big as trucks. The rings are probably the remnants of a moon, one that strayed too close and was torn apart by Saturn's pull. Or perhaps the moon was pulverized by an impact. Either way, the rings are too near Saturn to remake a moon. They're within what astronomers call the Roche radius. Outside the limit, moons can form. Inside, material spirals into the planet, the future fate of Saturn's rings.
The specific type of impact needed to form a moon as large as our moon is actually fairly unique.
Had Orpheus hit head-on, Earth wouldn't have a moon. The angle of impact would throw up a ring of debris, but because it was within the Roche radius, the debris would rain back to Earth.
Yet in other cases, we find that after an impact, perhaps we form 2 moons that are actually stable for tens of thousands of years.
Canup tries every angle in her Orpheus impact models. A third of her simulations yield 2 small moons, but they're unsustainable partnerships. Alas, 2 moons wouldn't last till today.
What a sight that would have been to have 2 moons in the sky, in very close to the Earth.
With 2 moons, the smaller inner moon either falls to Earth, or the moons ultimately collide. But to produce our moon, Canup takes the most oblique approach.
We found that if you made the impact occur at a very off-center angle, so that the impactor almost missed the proto-Earth entirely, that configuration was very good at placing material into orbit. An off-center impact partially destroys the impacting body, which then passes away from the Earth and temporarily recoalesces before coming back in again for a second hit.
A double whammy.
The entire impact process probably took on the order of a couple days, but it would have been a very bad weekend to be on the Earth.
But our prize is the Moon. It forms just outside the Roche radius, 14,000 miles from the surface of Earth Mark II. Accumulating ejecta from a hot disk of debris, our Moon rapidly coalesces in from just 1 to 100 years.
If we had been on the Earth right as the Moon formed, say 100 years after the impact, the Moon would have been truly an enormous sight in the night sky. When you viewed the Moon right after it formed, it would have appeared 15 times as large in the night sky as it does today. That would have been quite a sight.
On our devastated planet, it's hell on Earth. Volcanoes spew. The crust heaves. Lava rolls like an ocean. The Moon is so close that rock and magma are tidal. The lunar pull is 4,000 times greater than today. Earth writhes and belches. In the seas, every wave is a tsunami. Gradually, through 4.5 billion years, Earth cools and calms. Initially, vast tidal forces cause the Moon to rapidly pull away. The spin of both bodies slows. Our day lengthens from 4 hours to 24. Tidal action continues to slow the spin of Earth and keep the Moon in retreat. Scientists know by examining rock layers called tidal rhythmites. They show the frequency of prehistoric tides. Marjorie Chan of the University of Utah hunts rhythmites in Big Cottonwood Canyon. Eons ago, these were layers of sediment left by tides in a river estuary.
Some of these tidal rock layers are just paper thin, and it's like each piece of paper is a story or page out of a diary telling what's happened a billion years ago.
Chan's findings are rock solid. Primitive tides are more frequent, and the days far shorter.
It's amazing that these tidal rhythmites can tell us that a day was only 18 hours long, because we can count some of the tidal rhythms. We can see how many rhythms were in a day, how many days were in a month, how many months were in a year. And we use those calculations to show how the Moon has been moving away from the Earth over time.
From 14,000 miles at the start, the Moon is now 234,000 miles from Earth. Today, when all three bodies align, the Moon can precisely cover the Sun. On Earth, we see it as a total eclipse, an astonishing cosmic coincidence. Such eclipses are further evidence that the Moon is receding from Earth. This is a total eclipse today, but it looked like this when the Moon was closer to Earth. In future, when the Moon is further away, a total eclipse will be a thing of the past. Ancient eclipse records reveal that as little as 2,000 years ago, day length is fractionally shorter than today. Had it been constant, the solar eclipse of 136 BC would have followed this line of totality. Instead, because the day was then shorter by a 20th of a second, totality sweeps east through Babylon. More than a quarter century ago, Apollo astronauts set up reflectors on the Moon. Today, they're targets for astronomers at the McDonnell Observatory, Texas. By bouncing laser beams off the reflectors, the speed at which the Moon is receding can be measured to within a hair's breadth. The gap is widening by 1.5 inches a year. From this, over 4.5 billion years, the Moon in our skies has shrunk to this. The Moon's gravitational pull keeps Earth on an even keel, an average tilt of 23 degrees. By contrast, Mars lacks a big moon stabilizer. Consequently, it wobbles on its axis. over millions of years, the tilt can vary from 0 to 90 degrees, playing havoc with its climate. Imagine Earth like this. In Paris, at the Bureau de Longitude, astronomer Jacques Lascar does just that. What would happen to Earth, he wonders, without our big, lucky moon? First, he models Earth with the moon. Our axis may move in a circle, but always at 23 degrees. Remove the moon, and the circular movement slows, but Earth goes loco. Lascar's calculations spell chaos. Take out the moon, and we lose all stability. Earth reels around the inner solar system. Lascar has no doubt we depend utterly on our partner in space.
If we had no moon, the axis of the Earth will wobble chaotically between 0 degree and 90 degree. And the climate on the Earth would change dramatically. So we can say that the moon is a climate regulator for the Earth.
Even with the moon, Earth suffers mini wobbles. As a member of a NASA team seeking the origins of life, Lynn Rothschild knows that even the smallest change in tilt has profound effects.
There's some researchers in Germany that have proposed that the reason that civilization on Earth started in the Nile Delta region and not the Sahara, where there were large groups of humans at the time, was because of the obliquity of the Earth shifting less than a degree.
North Africa's lush Sahara turns brown and barren. Today, it's Earth's biggest desert, product of a planetary teeter.
Without the moon, we would be getting shifts in obliquity of 20, 30 degrees, 40 degrees, 50, more. And so compare that to this change in obliquity of less than 1 degree that caused the mass migration of humans, and you can start to imagine what a serious issue this would be for life on Earth.
So, as we lose the moon, there's cause for concern. Could this be Egypt as Earth starts to wobble? Is this the Sahara of the future? Does Antarctica become a blazing desert? These are the prospects if we lose the moon and Earth tips over.
You suddenly have summers that are incredibly hot. Over land, you're talking about maybe over 100 degrees centigrade, over the boiling temperature of water. On the other hand, you have winters where you're well below freezing, maybe as cold as even dry ice, incredibly cold temperatures.
Ice sheets advance and retreat across the equator. Worse still, as Earth wobbles chaotically, the polar caps melt, the oceans flood, islands disappear, our coastal cities are inundated. It's a fact. The moon is leaving us. The further it goes, the less it will stabilize our planet, and the slower Earth will rotate. Our day will get longer and longer. One means of slowing the moon's retreat could be dam building, not across rivers, but oceans. It's science fiction, but we have millions of years to develop the technology. We're losing the moon because of tidal friction. Reduce the ebb and flow of our oceans by damming them, and we could slow the rate of the moon's recession. Equally bold is the idea of the late Alexander Abian of Iowa State University. He suggests hijacking a moon from Jupiter and parking it in Earth orbit. This moon, Europa, is big enough for the job. It doesn't replace the moon. Europa just helps keep our planet upright as the influence of our moon declines. But full moon spells trouble ahead for hospitals, prisons, and the streets of any city.
It just seems as though something tends to happen when it gets a full moon. You always seem to have some kind of problems. It just seems to be something in the air that gets people excited, sometimes in the wrong way.
From new moon to full moon, science explains the lunar phases. They're because only half the moon is sunlit, and we see a varying amount of that half. What science doesn't always explain is the effect of these phases on terrestrial life. Why is the practice of certain yoga thought to be dangerous at full moon? Are more babies born at full moon? Does the moon's 29.5-day orbit of Earth, the lunar month, influence the menstrual cycle? For primitive man, full moon means that he has light to hunt. There's a theory that this has locked the menstrual cycle to the lunar cycle. While men hunt, women can afford to be infertile. But in the dark days around new moon, when men are at home, women should be fertile for the survival of our species. In nature, once a year, Pololo worms rise to the ocean surface to mate on the night before a new moon. Easy pickings for these South Sea islanders. Coral spawns on the Great Barrier Reef. It only happens at full moon in November, the lunar signal for 1,000 species to reproduce. When tides are highest at new moon and full moon, sea turtles come ashore at night to lay their eggs, the safest time to incubate the young. As the moon regulates tides, so tides regulate habits. Only at low tide do these sand-burrowing crabs emerge. On the Galapagos Islands, marine iguanas anticipate low tide by up to 2 hours. It gives them a head start on the way to the feeding grounds they share with fur seals. The French wine harvest. Growers here believe that at full moon, lunar influence is high and maximum energy flows to the grape. So in France, growers like to pick around full moon, and they rack at new moon, when lunar influence, they claim, is lowest, sediment least perturbed, and the wine clearest. Life on Earth is undoubtedly subject to the rhythms of the moon. What's now emerging is that the impact that formed the moon may have hastened life itself. Greenland, 1999, and a jaw-dropping discovery.
We are flying into camp at this very remote place in West Greenland, and you can only get here by helicopter. And from the camp, we will walk out to the site where we will open Chapter 1 of the history of Earth.
3.8 billion years ago, this rocky outcrop is part of an ocean floor. As a native Inuit, Minnick Rosing is first to tap its secret.
So this is the oldest rock on Earth. This is the oldest material you can put your hand on, and if you want to touch something that's older than this, you would have to go to the moon to find it.
But moon rock, however old, contains no hint of life. Back on Earth, Rosing's Greenland rock does, and that's his great discovery. These layers contain carbon, evidence of complex plankton. That plankton exists so early predates previous estimates for the start of life by 200 million years, pushing it back closer to the lunar forming impact.
That was really a mind-boggling experience because life was not supposed to be on Earth at that time, and if it was, definitely it was not supposed to be in life forms that could have lived in the open oceans.
Previously, early life is thought to exist only in extreme environments, feeding off the gases of deeply submerged volcanoes. This man brilliantly explains the Greenland findings. As a member of the National Academy, he advises the US government on science. Norman Sleep believes the moon-forming impact of Orpheus kick-starts life.
Earth Mach 1 died when Orpheus hit. This is Earth Mach 2. If we are on Earth Mach 1, we'd be now under 3 kilometers of water. We'd have no oxygen to breathe.
Sleep's theory is radical. Orpheus blows off half the oceans of Earth Mach 1 and conjures a new atmosphere. quite possibly there's aquatic life on our protoplanet. Earth Mark I isn't short of water. Orpheus may have life too. But that impact takes no hostages.
The impact completely restores the Earth to a clean slate. Any life forms that existed on either the Earth or Orpheus, that was the end of them.
But his hunch is that Orpheus actually kindles life on Earth.
There may be a direct connection between life getting going on the Earth and the moon-forming impact.
Sleep believes that, like Earth Mark I, Orpheus has an iron core. On computer, these cores are blue. So violent is the impact, they merge.
When Orpheus hit, large amounts of iron were mixed into the Earth. This iron reacted with water, produced hydrogen. This produced a reducing atmosphere, which is essential for life getting going.
Pass electricity through it, like lightning, and the precursors of life may spark. In 1952, a celebrated experiment does just that. Simple amino acids are created in a test tube by Hal Urey and this man, Stanley Miller. But they lose favor as colleagues insist early Earth lacks the right conditions, a so-called reducing atmosphere. But now we know the Orpheus impact may have produced that atmosphere. But suppose there is no impact. How does our planet fare?
Earth Mark I would just be ocean. You might see a few small pieces of land sticking up, a little bit of Tibet, maybe the top of Hawaii, Mount Everest, but it'd be essentially covered with water. Without the impact, we'd definitely not have humans on the Earth. This documentary might be being made by other life forms, but they'd definitely not be humans.
We can only speculate about the creatures that evolve on Earth Mark I.
It's really fun to try to figure out what life would be like on the Earth. Would we have intelligent life? If we hadn't had the lunar forming impact, I think life on land would be very different. In fact, there might not be life on land at all.
And with no moon to slow our spin, Earth is hostile and frantic.
You would have a very fast rotating Earth. With just the sun and no moon, we'd have very fast days, about 3 times as fast as we have today. Sun up, sun down would all come much quicker. Everything that goes on during the day would be much faster.
And a grotesque climate. Winds howling at hundreds of miles an hour. Non-stop dust storms. No human could evolve here.
So you really have to turn to the aquatic environment and think, well, what in the aquatic environment would be considered intelligent? Octopus and its relatives are all rather intelligent. They can do things like actually build little houses for themselves with their tentacles. They can, to some extent, have feelings. They have eyes that are almost dead ringers for vertebrate eyes. They're absolutely fascinating. And so you sort of have to picture that the cephalopods, the octopus and the squid and so on, are really going to be the geniuses of a moonless Earth.
But with the moon, those cephalopods don't evolve to rule Earth Mark II, or even our oceans. Most perish in the impact 65 million years ago that slays the dinosaurs. Mass extinctions occur about once every 100 million years. In the past, the moon could have shielded Earth from such impacts, but statistically the chances are small.
To an evolutionary biologist, I don't really care as much about statistics. All I need is one impact that would have affected evolution. And the fascinating thing is that there's no way to prove it. There could have been a time that the moon actually protected us, actually saved us by being at the right place at the right time and intercepting an impact that otherwise would have done severe damage to life on Earth. In other words, caused a mass extinction.
The moon may have saved our planet. It's about to become our stepping stone to other planets.
As chance is a very important aspect in planetary growth, the moon can be viewed as a symbol of luck. If a tiny dust grain were moved very slightly, early in the history of planetary growth, by the width of a human hair even. That could affect a collision 1 million years later. Orpheus might have missed Earth altogether.
Perhaps sending it careening into Venus.
This could produce a system which would be very similar to our terrestrial planet system today, except that Venus would be left with the large moon rather than Earth.
Leaving any intelligent life on Earth marooned on Earth.
3, 2, 1, 0, and liftoff of the Lunar Prospector spacecraft on a voyage to rediscover the moon.
But since we have the moon, we have the chance to colonize the solar system, and we're on the way again.
I've always looked at the moon as a complete world. People tend to forget it is a world. It's a very big place. The surface area of the moon is equal to North and South America combined.
But despite a fleet of probes and 6 Apollo landings, our celestial partner remains a relative stranger.
Here we are with a complete world that we know virtually nothing about. I make the analogy quite frequently that if you had 6 crews spread over California and they worked 3 days, you'd never found the gold, you'd never found the oil.
And you'd never have found the water. Water delivered billions of years ago, it's thought, by comets. Deep in dark craters at the lunar poles, ice may lie preserved. The clue comes in 1998 when Binder's probe, Lunar Prospector, detects hydrogen, a possible sign of water.
The amount of water that we're flying over right now is roughly equivalent to that we think is found frozen in the polar regions of the moon using the data from Lunar Prospector. If this is the case, then we are ready for lunar colonization.
If water's confirmed, it's worth its weight in gold.
We wanted to get people back studying the moon and understanding that this is the future of humanity and it's the beginning of the colonization of the solar system. And I believe the Prospector has done that. I want to see humanity on the moon, and I want to see humanity spread throughout the solar system, and this is the beginning point.
As Lunar Prospector runs low on fuel, Binder has an idea. He targets a crater at the South Pole. Would a deliberate impact splash up the proof of water? Sadly, no. But it was a long shot. David Gump is the new generation, a space entrepreneur who plans a commercially funded mission to the moon. At his base in the Mojave Desert, California, Gump has the prototype of a reusable rocket. From Earth orbit, it's to launch a lander to search for water.
There is no actual proof that water is there. So our robot will land at probably the South Pole, near what's called the Peak of Eternal Light, and then go into one of these permanently dark craters at the poles to see if there is ice that could be recovered to make our first space oasis. If we can confirm that useful quantities of water actually exist at the lunar poles, it means we could refuel our spaceships there, and it means that missions to Mars and missions deeper into the solar system finally become feasible. It's the first time we could actually sort of live off the land as we explore space.
Gump's vision hinges on lunar water. It sustains life and, split into liquid hydrogen and liquid oxygen, makes rocket fuel. His moon is a spaceport.
I think the moon is crucial to having a stepping stone to the rest of the solar system. The solar system is a really big place, so having a training ground where we can prove ourselves and our equipment close to home, so if there is a problem, you can call for help, is crucially important. If you're on the way to Mars and you have a problem, you're pooched.
If there's water, lunar colonies are next, but not the cool modules of science fiction. More the adobe structures of the Mexican deserts and the U.S. Southwest. Moon pioneers will fashion their accommodation from lunar dirt. NASA is taking note.
The next time when we go to the moon, our suits are going to be very high technology, but we will have to depend on basic natural resources for our dwellings.
The watchword is economy, living off the land. the first moon dwellings could resemble these huts at a museum of traditional building in California.
Every pound of material we carry from here to the moon, it costs 2 to 3 pounds of gold. Therefore, it's vital to be able to utilize what exists there.
Tubes filled with moon dust and stacked in coils.
It seems to be ironic that we are going back into history. It really is not going back into history. It's taking the best of what civilization has given us and moving it forward into the future.
Like the roller coaster? Here, space architect Thangavelu meets rocket scientist Anthony Zupero. The topic is transportation and the cheapest way to get off the moon.
You think this is going to be similar to what we find on the moon, right? I suspect so.
Could this lift us from the moon? A magnetic levitation ride that puts us on course for Mars. NASA is funding development. With 1/6 the gravity of Earth, it's 100 times cheaper to launch space vehicles from the moon. But imagine spending 3 years in here, headed for Jupiter.
Weer geen promotie gemaakt. De Power Zone, vanavond om 12 uur op Discovery Channel. Met Discovery.
Drenkeling Zuidkant Maasbrug over.
Waar we ook zijn. Wie we ook zijn. Allemaal delen we die fascinatie voor het licht dat onze adem doet stokken.
Signalement vluchtauto, grijze Saab, kenteken IF36GD.
Donderdagavond op Discovery is Crime Nights. Elke donderdag vanaf 9 uur.
Space is horrible. You have to have some gravity or your immune system doesn't work. Your bones become chalk. You gotta have gravity. The only way to get gravity is to have this big spinning device and you're thrown against the walls.
And that's what Zupero plans, a gigantic ring inflated with water ice from the moon. Ice stored at a filling station in lunar orbit.
You don't build your spaceship, you inflate it. You have a plastic bag the size of a football stadium that looks like a huge tire, and you inflate the walls with water, and you've got an ice spaceship.
The ring spins, and within it the travelers have gravity. Water ice stored in the walls powers a steam rocket. For the return, refueling is on one of the icy moons of Jupiter.
I never would have figured that a steam-powered rocket, a clunker, would take 100 times more than the next best rocket. And that means that you would take 100 people from here to Jupiter and to all the moons of Jupiter, Ganymede, Callisto, Europa. Absolutely incredible.
All that Zupero needs to make his steam rocket work is the power plant from a nuclear submarine. He might also recruit some submariners.
Submarines were the first platforms that the space program turned to find out how people
would react to long-duration trips in isolation with just each other. And they learned a lot from the submariners. And I think submariners are the kind of people who'd be interested and who would find the opportunity to do something like that an exciting prospect.
The drawback for the moment is the nuclear factor.
A world that would permit nuclear explosive propelled spacecraft would be far different from the present. Nuclear weapons would be totally abolished. If we should ever achieve that agreeable social order, marvelous opportunities abound.
As a yachtsman, Solem draws a parallel with his own nuclear spacecraft, Medusa.
Well, what this beautiful America's Cup yacht, America One, has in common with the Medusa spacecraft is the spinnaker. The spinnaker is a very lightweight sail launched ahead of the craft, and it's driven directly by the wind. In the case of the spacecraft, this would be driven by a series of nuclear explosions.
Medusa needs the moon because the nuclear explosives that propel the spinnaker are encased in moon dust. Medusa can travel at tens of millions of miles an hour.
Medusa is capable of providing us with interplanetary travel on very human timescales. It may even take us to the stars.
And around those stars, are there planets that bloom like Earth? Or does such a flowering need the luck that spawned our moon?
Now that we're discovering planets around other stars, how important is a moon in creating an Earth-like environment? If we have 100 planets around other stars, and 50 of them have Earth-like planets, out of those 50 Earth-like planets, are they all like the Earth, or do you only get something that's really like the Earth if you have a moon going around it?
Recently, we've begun to ask the question, how likely is it to form an Earth-like planet with a massive moon like our moon in other solar systems? These are critical questions because the moon seems to be an important element to habitability and a stable climate on our planet. And so in order to answer the question, how likely are other Earths, we really have to know the answer to the question, how likely are other moons?
To date, more than 20 planets are discerned around other stars. None is Earth-like. One day, aboard Medusa perhaps, we may spy a tranquil blue planet with a single large moon.
Na de onderbreking zijn we terug op aarde en terug in de geschiedenis. In deel 4 van The Great War, hoe de soldaten aan het front letterlijk kanonnenvoer werden in Slaughter.